Okay, so the next thing we want to do is multiply and divide rational expressions. So we're multiplying and dividing fractions. Now, if you're wondering why aren't we adding or subtracting rational expressions, we will. We'll do that. We'll do that next. But it turns out it is usually easier to multiply and divide than it is to add or subtract, at least in terms of fractions. And some of you probably already know that by now. So let's start with multiplying, right? Multiplying, again, pretty easy. P over Q times R over S. You just multiply across, right? You get P times Q over R times S. But what I want to emphasize here is that this is usually not the way to go, in the sense that you usually have to simplify this, right? So we should say and simplify, right? And we just did simplifying, right? Essentially, it's two steps, right? Factor and cancel. Factor and cancel. And what I want to emphasize is that if you're going to do that, you probably should do that originally. You should do that to the first two fractions rather than multiply first and then simplify. Okay? So yeah, let's look at an example of that. Okay, so let's start with one that you've probably done before, right? 91 over 196 times 168 over 130. Okay, so again, this is easy because it just involves numbers, right? You don't see any, x squared minus 4 or anything. That'll come later. So let's just start with this. Okay, so if you took my little hint here that we want to simplify each of these numbers first. And by simplify, we mean essentially just write them in their prime factored form. So we want to find the prime factorization of all these numbers. So for example, 91 is just 7 times 13. Right? So, yep, 7 times 13. And 196, the first denominator, is, well, let's see, you can do 4 times 49, right? And 4 is 2 times 2. 49 is 7 times 7. So sure enough, the denominator, the first denominator, is 2 times 2 times 7 times 7. And you can write them with exponents if you want. In this case, I'll leave it alone. And then 168 is 8 times 21. So 8 being 4 times 2, and 4 is 2 times 2, and 21 is 3 times 7. So 2 times 2 times 2 times 3 times 7. So, yep, so 2 times 2 times 2 times 3 times 7. And then finally 130. So 130 is, well, 10 times 13. And 10 is 2 times 5. And those are all prime, right? So 2 times 5 times 13. All right, so I think we're factored completely, right? All these on the right here, these are all prime numbers at this point. So once we factored completely, now we do the canceling, right? So anything that's the same in the numerator and denominator cancels. For example, 7 divided by 7 is 1, right? But notice there's another 7 way over here on the right, and that 7 cancels with that 7. Likewise, 13 divided by 13 is 1, so they cancel. And a whole bunch of 2's, right? This is 2 divided by 2. This is 2 divided by 2. This is another 2 divided by 2. And I think we're done. I don't think there's anything else that cancels, right? So all that's left in the numerator is a 3, and all that's left in the denominator is a 5. So this reduces to 3 over 5. Okay, so this is the way you should be thinking of it, right? Factor everything first, cancel everything, and then multiply whatever's left over. In this case, it's just 3 over 5. Because if you take the original problem too literally here, so this was 91 over 196 times 168 over 130, right? If you took this literally, you would multiply 91 times 168 and then divide by 196 times 130. And here's the problem with that, right? 91 times 168 is 15,288. And 196 times 130 is 25,480. Okay, so great. So we did that and we got this fraction here. But I can assure you this is not in lowest terms, so we would have to reduce it. And how do we do that? Well, we would have to do the factor trees for 15,288. You know, this might take a while, right? This is not going to be just a couple of numbers here. And then you have to do the same thing with 25,480. And you have to do all the factor trees all the way down. Right? So you see the issue, right? The numbers are just massively bigger. They're just so much bigger. And, you know, you can use your calculator, of course, but it's still going to take you a while. So even though there's just the two numbers, they're really, really big. Right? Whereas the way I did it is I took these four numbers here, the two numerators and the two denominators, and I factored those. And even though there's four of them, you know, they factor pretty quickly because they're relatively small numbers. Okay, so it's better to factor the smaller numbers than to factor the bigger numbers, in my opinion, right? And so this is the way we should be thinking of it, right? You want to simplify all these things, all these factors first, you know, get them into their prime factors, and then it should be pretty easy to see what cancels and what doesn't. Okay. Okay, so here's another example, this one being a little more difficult than the last one. So we want to multiply and simplify 2x squared minus 8 over 10x plus 30 times 12x plus 36 over 3x minus 6. Right? All right, so yeah, the one thing you don't want to do is just multiply straight across, because you're making it worse if you do that. Right, you're getting bigger numbers, or in this case, just a massive mess here. Right, so yeah, you could FOIL this, of course. 2x squared times 12x is 24x cubed, blah, 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 right? This is going to be 30x squared plus a bunch of other stuff. But that's the whole idea here, is that you're turning these into terms, not factors, right? Remember, you want to factor and cancel. So multiplying, what we did here, right, is the exact opposite of factoring. Right? We want to break things down into smaller things, not bigger things. Right? So yeah, so this is not the way to go here. Right? You want to factor and cancel first. It's going to take a while to erase all this, but I'll eventually get to it. Right, so let's just start with the first numerator on the left. Right, we have 2x squared minus 8. I'll write it way down here. Okay, so the GCF is 2. We factor out the 2, and we're left with x squared minus 4. But you've seen this before. X squared minus 4 is just x minus 2 times x plus 2. Right, so the first numerator is just 2 times x minus 2 times x plus 2. Now we factor the first denominator, 10x plus 30. Well, you can factor out a 10, and you're left with x plus 3. And the 10, of course, can factor as, right, 2 times 5. So the denominator here is 2 times 5 times, I'll put the 5 in parentheses, times x plus 3. Okay. Now let's go on to the second numerator, the 12x plus 36. So the GCF here is 12. You factor out the 12, and you're left with x plus 3. And the 12 is actually 2 times 2 times 3. So yeah, I'm going to factor the numbers as well. 2 times 2 times 3 times x plus 3. And then finally, the last denominator, the second denominator, 3x minus x. Just take out the 3, and it's 3 times x minus 2. Okay, so clearly, right, it's a lot of factoring here. It's a lot of factoring. There's 4 things we had to factor, right? 2 numerators and 2 denominators, right? But at this point, each of these is relatively routine. There's nothing tricky about it. Right, so I think we factored everything completely. Now we just have to cancel, right? So that's the fun part, right? 2 divided by 2 is 1, right? 3 divided by 3 is 1. And x minus 2 divided by x minus 2 is also 1. And x plus 3 divided by x plus 3 is also 1. Anything else? So let's see, what do we have for the numerator here? We have 2 times 2, which is 4, and then we have the x plus 2. And what about the denominator? Well, it looks like we canceled everything except this 5 here. Yep, there's still a 5 in the denominator. So there's our answer, 4 times x plus 2 all over 5. Okay, so that's how it works, right? Simplify is simply, as usual, factor and cancel. Factor and cancel. Right. Do not try to cancel anything until you factor. Okay? Right. So yeah, you have to be very careful. You're not doing 12 divided by 3 is 4. Right? You can't do that because, right, the 4 doesn't multiply. The 12 doesn't multiply the 36. Right? Got it. All right. Next one. Okay, so next example, multiply and simplify 4a squared minus 8a all over ab minus 2b plus 3a minus 6 times 8b plus 24 over 2a plus 4. All right, so again, a lot of things we have to do to factor here, right? So we want to factor and cancel, factor and cancel, factor and cancel. So let's start with the first numerator here, the 4a squared minus 8a. So the GCF here is 4 and an a, so we can factor out the 4a, and we're just left with a minus 2. So the first numerator is 4 times a minus 2. Right. Now how about the first denominator? So the denominator is ab minus 2b plus 3a minus 6. So here the GCF is 1. And because there's 4 terms, it looks like we're going to be grouping here, right? So factor out the b, you're left with a minus 2. From the last 2 terms, we can factor out a 3. We're left with a minus 2. So this factors as a minus 2 times b plus 3. And you can see already that we're going to cancel the a minus 2's here. Okay, you can do that now. I would wait till later, right? Let's factor everything first before we try to cancel anything. Okay, so we have the second numerator, which is 8b plus 24, and here the GCF is 8. So you factor out the 8, and you're left with b plus 3. So 8 times b plus 3. And the second denominator, boy, that's easy. 2a plus 4, just factor out the 2, and you're left with a plus 2. So 2 times a plus 2, right? Okay, so I think that's about it. I mean, we could go further here, right? You can factor the 4 and the 8. On the other hand, let's take care of that later, right? So remember, a minus 2 over a minus 2 is 1, so we can definitely cancel those. We can also cancel b plus 3 over b plus 3, right? And so what are we left with? The numerator is 4 times 8 times a, and the denominator is 2 times a plus 2. Okay, so 4 times 8 is 32. Right. So 32a over 2 times a plus 2. And 32 divided by 2 is really just 16. Right. So yeah, we could have gone further here, factored the 4 as 2 times 2, factored the 8 as 2 times 2 times 2, and then just canceled one of the two, say this 2 and this 2, and now you're left with 2 times 2 times 2 times 2. So that's 2 to the 4, which is 16. So either way, right? So I think that's as far as we can go here, right? So we're left with 16a in the numerator and a plus 2 in the denominator. And that's it. So again, multiplying and simplifying is just a lot of factoring and then hopefully a lot of canceling, right? I mean, in some cases it might be a trick question and there's nothing to cancel, but in most cases there's at least one factor that cancels, and in this case there were several. Okay, so that's multiplying. What about dividing? How do we divide fractions, right? So this is p over q divided by r over s. Okay, so dividing fractions is really just multiplying by the reciprocal. This is p over q times s over r, right? And so this is just p times s over q times r, although remember, you want to simplify before you cancel, before you multiply, right? Simplify first and then multiply, right? So a lot of people remember this as you keep the first fraction, right? P over q stays p over q, right? You keep that. Sorry about that. Keep that. And then the division you change to multiply, right? So you're going to change the division to multiply. And then the second fraction, the r over s, well, that just got flipped upside down. So you flip the second fraction, right? So keep, change, flip. Right? This is when you're dividing. Right? So just to reiterate, oh, I don't want to use red. Sorry about that. So, right, so you just have a over b divided by c over d. Before you do any factoring and canceling and things like that, you're going to keep the first fraction a over b, change to multiply, and then flip the second fraction, make it d over c. Right, and then you factor and cancel, essentially just like we did when we were multiplying, right? So division is really just a multiplying problem again, but you got to remember to flip the second fraction before you multiply, right? So you're multiplying by the reciprocal. Okay, so let's start with an easy one. This is 10x plus 20 over 3x minus 9 divided by 5x plus 10 over 4x minus 12. Okay, so first step is keep, change, flip, right? So we'll keep the first fraction, change the division to multiply, and then flip the second fraction. So it becomes 4x minus 12 over 5x plus 10. Okay, so now it's a multiplying problem, and we already know how to do that, right? You got to factor everything and cancel. So from the first numerator here, the 10x plus 20, we can factor out a 10. Right? And you're left with x plus 2 as the other factor. For the first denominator here, we can factor out a 3. This is 3 times x minus 3. And then for the second numerator, we can factor out a 4. We're left with x minus 3. And then the 5x plus 10 factors as 5 times x plus 2. Okay. So at this point, it's pretty clear. We have an x plus 2 in the numerator and an x plus 2 in the denominator, even though they're in different fractions, right? One's in the first fraction, one's in the second. As long as one factors in the numerator and one is in the denominator, you can always cancel those, right? And the same thing with the x minus 3. We can cancel those. So what are we left with? We're left with 10 over 3 times 4 over 5. So the hard way to do this is to multiply 10 times 4 to get 40 and 3 times 5 to get 15. But then you have to reduce to its lowest terms, right? So 40 is, well, 2 times 2 times 2 times 5, and 15 is 3 times 5. So you can just cancel the 5s, and oh, that's it, right? Just the 5s. So 2 times 2 times 2 is 8, and the denominator is 3. So 8 over 3, I think, is our final answer. Yeah, so there's nothing wrong with doing it that way. But remember, you can factor the 10 as 2 times 5, and you can factor the 4 as 2 times 2. Oops, sorry, this is not an equals here. This is a times. We're multiplying these. There we go. And now just cancel the 5s. 5 divided by 5, right? So we're still left with 2 times 2 times 2, which is 8, and then divided by 3 times 1. So 8 over 3, same answer. Okay, so all of this mess here is really just equal to 8 over 3, provided that, you know, it's x is not 3 or negative 2. Those are the restricted values. We talked about those in the previous video. And I'm generally not going to ask you these in these problems here, but you should recognize that this is true if x is not equal to, negative 2 and 3. Okay, and so you might see this in the answers, in some of the answers on the practice test. Really, I'm just looking for the 8 over 3 and looking to, you know, again, show all your work here, show what you canceled and so on, and what you factored. So yeah, the answer is 8 over 3. But remember, there's always these restricted values that we have to worry about, in this case, negative 2 and 3. Okay, here's another one. Divide and simplify 3y squared minus 2y minus 8 over 3y squared minus 5y minus 12 divided by y minus 2 over y minus 3. Okay, so go ahead and try that. All right, so first thing you do before you factor anything, I guess once you get used to this, you could do it all at once, but I'm going to go one step at a time here, right? First step is to keep change flip. Okay, so we just flip the second fraction, and now we just multiply, right? Y minus 3 over y minus 2 instead of y minus 2 over y minus 3. Okay, now we have to factor, right? So for the first numerator here, this does not look easy, so let's do this, I guess let's do this over here. 3y squared minus 2y minus 8. So the GCF is 1, so this looks like an AC method. So a times c, 3 times negative 8 is negative 24. So what two numbers multiply to negative 24 and add to negative 2? Okay, so spoiler alert, right, it's negative 6 and 4. So let's do 4 and negative 6, right? So we split this up, 3y squared plus 4y minus 6y minus 8. And factor by grouping, so factor out the y, you get y times 3y plus 4, and then negative 2 times, again, 3y plus 4. So we're going to factor this as 3y plus 4 times y minus 2. So that's our first numerator, 3y plus 4 times y minus 2. And then the denominator. So this is done in much the same way. We still have 3y squared, but now it's minus 5y minus 12. So in this case, a times c, 3 times negative 12, is negative 36. So what two numbers multiply to negative 36 and add to negative 5? Right? Negative 9 times 5. I'm not going to go through the whole list. Hopefully you did that, if you had to, because negative 9 plus 5 is... Oh, sorry, negative 9 times 4. Oops. Yeah, negative 9 times 5 is negative 45, so that's not going to work. Negative 9 times 4 is negative 36. And negative 9 plus 4 is negative 5. Okay, so negative 9y plus 4y is 5y. So that's how we split that up. So 3y squared minus 9y plus 4y minus 12. And when you factor by grouping, you get 3y times y minus 3 plus 4 times y minus 3. So this factors as y minus 3 times 3y plus 4. And so yeah, that is our denominator here, y minus 3 times 3y plus 4. All right. Now, how do we factor y minus 3, the second numerator? Right, we don't. Y minus 3 is prime, so we can leave that alone. And the same for y minus 2. That's as simple as it gets. Y minus 2 is already prime. All right, so what cancels? Well, 3y plus 4 over 3y plus 4. Right? And y minus 2 over y minus 2. Right? And y minus 3 over y minus 3. So what cancels? Well, everything. Okay, so this is a little tricky here. Now, what's the answer? Right, so if everything cancels from the numerator and denominator, right, and the answer is 1. Right? The answer is just 1. And you might see that because it's, it's just like, 6 divided by 6, right? This is, well, 6 times 1 over 6 times 1. The 6's canceled, leaving you with 1 divided by 1, which of course is 1. Right? Yeah, so essentially we have the same thing in the numerator as in the denominator. So just like 6 divided by 6, right? It's just 1. Okay. Now, keep in mind that, the only difference is that, it's in, the numerator and denominator is in different order. But remember, when you're multiplying, it doesn't matter what order you're multiplying. You can do 2 times 3 to get 6. You can do 3 times 2 to get 6. So just because these are in different order, right, as long as you have the same factors in the numerator and the denominator, yep. So there's our answer, right? When you divide these two fractions, you just get 1. Kind of amazing, but that's what happened here. Okay. Okay, last one, and this is another divide and simplify. So you should try this. And yep, you're just going to keep the first fraction for now. Multiply by the reciprocal. So x squared minus 2x over 3x. Okay, so now you factor the first numerator is you can just pull out a 6. Factor out a 6 and you're left with x squared plus 4. Okay. The denominator, x to the 4th minus 16. So this is one we've seen before actually, not that long ago. Right, so this is the difference of two squares. It's x squared squared minus 4 squared. Right, so it's a squared minus b squared. So x squared minus 4 times x squared plus 4. However, x squared minus 4 is also the difference of squares. It's x minus 2 times x plus 2. So yeah, you got to keep going until you factor completely. So the first denominator here, oops, didn't mean to do that. Just make it a little bit longer here. So you factor x to the 4th minus 16 is x minus 2 times x plus 2 times x squared plus 4. And remember, the x squared plus 4, right, is prime. It's the sum of squares. Right. Times. So x squared minus 2x, you just factor out an x. And 3x. I don't see anything we can do with that. The 3x is already prime. Right. So now I think we're factored completely. Right. And at this stage, you could just multiply across here, right? We have 6 times x times x squared plus 4 times x minus 2 all over 3 times x, I'll just put that in front, times x minus 2 times x plus 2 times x squared plus 4. Okay, so I haven't been doing this, but it probably helps. So we can see we can cancel the x's, right? 6 divided by 3 is just 2. So this is just a 2 in the numerator. Right, I mean 6 is, 2 times 3, and we cancel the 3's, right? Leaving you with just the 2. All right, what else can we cancel? How about x squared plus 4 over x squared plus 4? And x minus 2 over x minus 2. And I think that's it for canceling. So what survived the numerator? Just the number 2. What survived in the denominator? Just the x plus 2. So there's our answer, right? This is 2 over x plus 2. Done. So I hope you're done. I hope you didn't go any further, right? I warned you about this earlier. It's very tempting to say, well, 2 divided by 2 is 1, so this should be 1 over x plus 1, but it's not, right? You cannot do that because you're adding 2, not multiplying by 2 here. Okay, so yeah, you cannot cancel the 2's because it's not a factor of the denominator, right? So yeah, it's tempting, but it's also wrong to do that, right? If it was 2 divided by 2 times x instead of 2 plus x, right, then you can cancel the 2's, right? This is just 1 over x because, right, 2 divided by 2 is 1. But here, that's a plus, not a times. So it's, right, the 2 is not a factor, it's a term. You don't cancel terms, you only cancel factors. Okay, so again, if you got that and you didn't cancel the 2's, great. And like I say, they're not going to get much more difficult than this. So that's multiplying and dividing rational expressions.